Hi everyone. In the last session, we have seen about how to use S-Trace and L-Trace for debug. We will be looking into threads now. So, what is a thread? So, a thread is a sequence of instructions within a process that can be executed independently of other code. So, any sequence of instructions which can be independently executed is nothing but a thread. So, multiple threads are present in a single process and they share the heap segment, data segment, code segment, open file descriptors. They share almost everything. They, what is different between each and every thread is it has its own thread ID. It has its own set of registers like stack pointer, program counter. It has a stack for storing local variables, return addresses, signal mask, and prior. So these are unique between all the other threads in a process. All the other are being shared between threads. So what are the advantages of threads? So it is very useful when you want to make a program appear doing two things at once. For example, you have a document, you want to perform real-time word count while you're still typing the text. So in this case, one thread can manage the user input and the other thread can continuously update word count variable. So the other advantage is better utilization of hardware resources. So we nowadays have laptops and desktops containing multiple cores. So using multiple threads inside a process, we can better utilize the hardware resources. The context switch between threads is faster when compared to the context switch between processes. So these are the few advantages of threads. What are the disadvantages or drawbacks of threads? We should carefully design multi-threaded programs as most of the resources of the process are shared. As we have the global data in threads, we should carefully design the program. Otherwise, there may be a race condition. Debugging a multi-threaded program is very much harder when compared to debugging a single-threaded program. So these are the few drawbacks of threads. Now let's start writing some of the thread programs. So, so as we said, each and every process have a single thread. So and each and every thread will have a unique thread ID. So how can I find out this thread ID? So there is a function known as getPID. We already have seen getPID, which will give us the process ID. There is one more function known as getTID, which will this is not a it is a system call, which will give us the caller's thread ID. So let's see into the getPID man page. So it's a system call. It gives thread identification. And you can see the return value is PID underscore. So get PID returns the caller's thread ID. In a single threaded process, where there is only one single thread, the thread ID is equal to the process ID. So in a single threaded process, PID is equal to process PID. But in a multi-threaded process, all threads have the same PID, but each one have a unique PID. So this is the difference. So this function is Linux specific and should not be used in programs which are intended to be portable. And glibc is not providing a wrapper for this system call. So you have to use syscall to call the pthread underscore, sorry, to call getTID. So there's no direct wrapper for system call. This system call you have to use syscall from system call. So how can I see? I can just show you an example. So I'm calling getPID to print me the PID, and then I'm calling syscall of sys underscore getPID. So by this syscall, I'm calling the system call get. So you can see in a single threaded process, the PID is equals to TID. Both are same. So what are Pthreads? So we are discussing about Pthreads. What are Pthreads? So historically, each and every hardware vendor, they used to develop their own proprietary version of threads. So as each and every hardware vendor had its own version of thread, it was difficult for the programmers to develop portable threaded application. So a standard was developed by IEEE, and the standard was known as POSIX standard. And Pthreads is a library which is actually following the standard, this particular standard. So we call Pthread also as POSIX threads. So POSIX threads is a standard for programmers to have portable code. How can I use Pthread? I have to include this pthread.h header file in our code, C code, and while compilation, I have to pass this. So this will link the Pthread library, dynamic library. So by default, your main program will have a single default threads. All the other threads must be created by the program. So how can I create a thread? I have this function pthread underscore create. When you see this pthread underscore create, it accepts 4 arguments. First one is a PID. So when you pass a pointer to it, this thread, pthread underscore t, it will give you the thread ID. Second one is the attributes. You'll see this ladder. Third one is the function which you want to call. And fourth one is whatever arguments you want to pass to this function. So when we create a new thread using pthread underscore create, which thread will start executing first, either the parent thread or the new thread. So there is no guarantee given as which thread will start. Like when you do a fork, there is no guarantee that parent process will run first or child process will run first. Similar this same case here. There is no guarantee like the parent thread will start first or the new thread will start first. It depends on the scheduling algorithm. The scheduling. So this is a simple example where we are creating a one more thread. So pthread underscore create. So I have created a data type for pthread underscore t ID, and I'm passing this. So this will be filled with ID will be filled. Attributes I am setting to null, and I'm giving the function name. So this function should have the prototype as this. It should return a void pointer. It should accept a void argument. Currently, I'm not passing anything to this function, and I'm just looking for error. So you can see to compile, I have to say GCC 1.c. If I say this, it will throw me an error saying undefined reference to pthread underscore create. So can you say where is at which stage this error is happening? We have different stages in well compilation. So where do you think this stage, this error is present? Which stage?
Linking state.
Yeah, it's at linking stage. So we have to ask LB thread. Now you can see hello world got printed and the while one is. So we can modify this code. So we can use our previous code where we are printing the TID of the process. I can copy this here. So in a multi-threaded process, the PID will be same and the TID will be changed. So we'll verify that. So you can see the PID is same, but the thread ID is this. So now I'm passing an argument to the function. So I'm just modified the previous code. I'm passing the argument to this function, and as it is a void star, we have to typecast it to our own argument, like we are passing a string, so I'm typecasting it to cast star. So let's run this code. It prints line its code. So if I want to pass more than one argument to my thread function, how can I accomplish that? Can anyone guess? Now we are only able to pass. We are only able to pass single argument. If I want to pass more than one argument to the thread function, how can I achieve it?
Structure.
Yeah, perfect. You can use a structure. So I can create my own structure, and I can define the structure according to my requirement, and then I can pass the pointer for the structure. In this example, I have a structure where I have two integers. I have created a member of the structure, and I'm passing the address here. And in this thread function, I'm just again typecasting it to struct. I'm accessing it. So I should be printing here 1 and 2. So you can see it printed 1 and 2. So we have seen one of the pthread API, which is pthread underscore create, which is used to create a new thread. So let's see two more APIs. First one is known as pthread underscore exit. So when a thread terminates, it should call pthread underscore exit function, which is similar to the process calling exit. So process calls exit when it terminates. Thread should call pthread underscore exit. So this will terminate the calling thread. It will not terminate the process. It will only terminate the calling thread. So it is not returning anything. And you can pass a return value in this. So this is similar to wait. So wait of status. So this is, but wait is used to wait for, so exit of status. And you have pthread underscore exit for exiting a thread. Then we have one more API, pthread underscore join. So this is equivalent of wait in processes. So wait in processes is used to block the parent process until the child process is terminated. Same case here. You have two arguments here. One is the thread ID, which you want to wait for this to complete, and what is the return value of the thread. So when you call pthread underscore join, the calling thread will be blocked until this particular thread is terminated. So what is the purpose of pthread underscore join? So by using pthread underscore join, I can wait for a thread to finish. And this is required to clean up the thread resources. And I can also get the return value of the thread here. What happens if I don't call pthread? So the resources which are used by the thread will not be freed up. So as a lot of threads are created, finally pthread create will fail because a lot of resources are being used. So you should call pthread underscore join to clean up the resources. So it's like you're calling wait in case of fork, right? Otherwise the child will become a zombie process. Similarly, you should also call pthread underscore join. So here again the same in this code. I'm printing before TID. I'm creating a thread. Now after this line, either this will execute or it can execute this. So in this I'm calling sleep of one and I'm printing thread function. And I'm blocking for this particular thread to complete. So pthread join will block the calling thread until the thread, which whatever the first argument is there, is terminated. After this process is terminated, next line, the calling thread will be unblocked, and whatever is after this pthread underscore join will execute. So before threads, then to in-thread function, and after thread. So using this, we no need of writing while one. Previously, we were writing while one in the code. Now we can just write pthread join, which will wait for the thread to terminate, and then I can terminate the main function. So again here we are, in this example, I am passing an argument to the thread, hello world, and I'm printing that argument here. And then I'm returning the strlen of this thing. So I'm storing that in result. In pthread join, instead of passing null as an argument, I'm actually taking as a result, and I'm then printing the value. So it prints a string length of the string whichever you pass as an argument. So we said pthread underscore exit is used to exit the thread. So I'm using pthread underscore exit here. So the PID will be same here. So you can see the PID is same. In this example, I'm creating 4 threads. So I'm creating 4 threads, and I'm passing in. I have a array of 4 integers. Not integers, should be integers here. I'm passing an array of. I'm creating an array of 4 integers, and then I'm passing it one by one value to the print function, and it is printing I am thread whatever value it is here. And then I'm blocking for waiting for each and every thread to terminate. So you can see I have to wait for the first thread to terminate, then only I can wait for the second thread to terminate. So I'm blocking in order here. So you can see all the threads got executed, and then joined for thread 0, 1, 2, 3, and the program got executed. You can see the order is changing each time we run the code. It's not constant. So there is no guarantee which thread will execute first. It all depends upon the scheduler. So what happens if a thread tries to join upon itself? So what is the functionality of pthread join? We are discussing about pthread underscore join. Right? What is the use of pthread join?
Wait for the thread to complete.
Yeah, it waits for the thread to complete. So this is a function known as pthread underscore self. It will give us the thread ID for the current thread. And we know each and every process will have a single thread. So what happens if a thread tries to join upon itself? So what is this code doing? It is trying to wait until the main thread terminates. But so will this work? So let's try this. So you can see it failed with error. So you can see the error number is 35. I can just say error number 35. So it says deadlock avoided. So you cannot wait for your upon yourself. So you cannot do like this. Pthread underscore join and pthread underscore. It should wait for some other thread. So we have seen pthread join. So what is the difference between pthread join and wait? Pthread join is used in threads. Wait is used in code. So first, in case of pthread join, thread must be set as joinable. So this we will see later. So there is an attribute for thread. Only if the thread is joinable, we can wait for that particular thread. If it is detached, we cannot wait for that thread. Whereas in case of child process, can wait for any of the thread. There is nothing like joinable and detached. Hierarchy. In case of threads, any thread can join on any other thread. There is no parent-child relationship here. Any thread can wait for any thread, but you just need to know the PID of the thread. Whereas in case of wait, there is a parent-child hierarchy. Only a parent can wait for a child process. Child process cannot wait for can wait for a parent process if it knows the child ID. But it will become a zombie process. Not a zombie process, it will become an author. Order. In case of threads, it is you have to wait upon a particular thread specified as a parameter to pthread join. Whereas in case of wait, if you pass null, if any of the child is terminated, it will come out from the blocking state. Signaling, there is no signal sent upon a thread's death, whereas in case of process death, kernel is sending a child signal to the parent. So these are the differences between pthread underscore join, which we are using in threads, and wait, which we are using in processes. So what is the thing which we need to be remembered for return value? So if I am returning a value from the thread function, what should I take care? What should I take care when I am returning a value from the thread? Can I return anything from the thread?
Should it not be local one?
Yeah, it should not be a local value. So we need to remember, right? When the pthread join collects the return value from the terminated thread, the return value must be pointing to someone else. It should not be a local value because the stack of the thread will be removed when the thread terminates. If you pass the address of a local variable as a return value, then that particular value will not be actually existing at that time. So you should be passing either. So what should we pass then? How can I pass a perfect return value? How can I handle the return value in case of this? Can anyone think?
We can pass in exit,
You can pass in exit.
pthread exit.
Yeah, you can pass in pthread exit, but if you pass a local value address there, then it's same, right? I cannot pass a local variable address there in pthread underscore exit. So what are the answers for this? So a return value can never be a stack variable. So you can create a structure and you can pass it the pthread create function, and there can be a return value field in the structure. The thread function will fill this while exiting the function. Or you can use a global variable to pass the return value. Again, you have to maintain synchronization here. Or you can pass a location to the thread and you can use the main thread to return the value. So you can pass in the argument the location and ask the thread to fill this value when it is exiting. So these are the ways by which you can handle the return value in case of threads. So what happens if I call pthread underscore exit from my main thread? So if I terminate the main thread, will the process be terminated? So I'm calling pthread underscore exit from my main thread. So my main function is the main thread. I have created 4 threads and then I'm calling main thread. So will the remaining 4 threads get terminated? Let's verify. So you can see calling pthread underscore exit from the main thread did not terminate the other threads. The other thread successfully got executed their code. So pthread underscore exit is only used to terminate the calling thread. It will not terminate the process. So here we are using pthread underscore exit. What happens if I say return 0? Will the remaining threads work or will they be terminated? I have created 4 threads, and after creating, I'm just returning from the main function. What will be happening to the remaining threads? What do you think? They will exist or they will be killed? Let's see them. So you can see no threads is executing. Sometimes they are executing depending on how schedule is. So if return 0 will terminate the process. So when the process is terminated, all the other threads which are running will also be gone. Now think what happens if I say exit from the thread. Will it only exit the particular thread, or will it exit the process? So I'm calling exit from the thread. Let's see what happens. So it exits the process. You can see the process is exited. So in this code, I've added a sleep of 20 seconds in the thread function. I'm creating 4 threads and I'm terminating a main thread. Okay. So just a new addition of the code is sleep of 20 seconds. So PS has an option of seeing threads. So we have seen a PS hyphen here, but there is an option to see the threads. So if you pass L, it will show you the threads. Threads are also known as lightweight processes. Hyphen A will select all processes. So if I say PS minus L, you can see in addition to the PID field, a new field is added which is known as LWP. So lightweight process ID. So now if I say LA, it's showing a lot of things. Let's say LS. So you can see when both PID and the LWP are same, this means it is a single threaded process, right? So you can see starting almost all are single threaded process, but at some point you will start seeing threads. So you can see here the PID is 690 and thread ID is 690. The PID is 690, thread ID is 732. This means it is a thread of the process 690. Then we have 734. We can see the PID and PID and PID are different. This means if the particular process is a multi-threaded process. So using hyphen L option, PS hyphen L option, you can verify the threads. You can see the threads in the PS command. Now here in this code, we have added a sleep. Let's see what happens. I run this in the background. So when I run this, the main thread creates 4 threads and it just exits. So until the process will exit only when all the 4 threads are exited. So the process is running now. I say PS minus LN and I grep for 4. So it's not showing here. So PS minus LN. You can see here 4. One of them is a defunct. So what is the defunct? Can anyone remember this? We have seen this defunct when we are doing processes.
Parent process dies.
When parent process dies, you will see defunct there. So there are two kinds of processes, right? Zombie process and autumn process. So when do you see defunct for PS command?
Zombie process.
Zombie process. What is zombie process?
When parent process does not call wait.
Yeah, when the parent process does not call wait. So the child process terminates. There are resources which will be freed only when the parent process calls wait. So until then, the process will be in zombie state. It will be showing defunct. So the same case is happening in case of this code. We have called pthread underscore exit of null. So as we call pthread exit, this particular calling thread is removed. And now as no one is calling pthread join on this thread, this has become a zombie process, zombie thread. So defunct is also applicable. Zombie thread is also applicable here. So main thread has exited before other threads in the process. Linux kernel will mark it as zombie. So how to prevent the main thread from becoming zombie? So you can allow the main thread to terminate before other threads in the application. So only allow the main thread to terminate after all the threads in the application is terminated. So you have to keep the main function alive until all the threads are terminated. Then only the process will remain. Then the process will terminate after your main thread is terminated. So let's see the performance if I use multi-process or multi-thread. So let's compare multi-process versus multi-thread. So we can create multiple processes using fork, multi-threads using pthread. Let's compare it. So this is the code. I have a macro, number of forks, assigned 50,000. So I have a loop here. I'm running this loop for this many number of times, and I'm creating new child processes. In case of error, I'm printing fork failed. In case of zero, which means it is a child process, I'm calling a function just to be doing increment operation. So I'm just doing exit, and I'm calling in the parent wait period. So I'm creating a process, and then the parent process is waiting for the child process to terminate. So I'm creating like 50,000 processes. So let's run this code. Let's see the other code. Here I'm creating threads here. So instead of creating processes, I'm creating threads using pthread underscore create. Again, I'm having a loop of 50,000. I'm calling the same function, thread function. I'm just incrementing a number, and I'm calling pthread exit. Here, after creating the thread, I'm also waiting for the thread to terminate. So the code is almost same. In the first example we have seen, we are creating a process using fork, and then we are waiting for the process to terminate, file process to terminate. Here also we are creating a thread, and we are waiting for this particular thread to terminate. So let's calculate how much time it takes for this particular process to execute. So what is the command for calculating the time? Like if I want to measure the time a command is executed, a process is executed, how can I use, what is the name of the command? Can anyone remember the command to measure the times?
Time.
Yeah, time is a command which will tell you how much time the particular process is running. So let's give the time 4. So this fork will run fork, and it will give us the time this fork runs. So it took like 12 seconds for creating 50,000 processes. So let's see the same thing using thread. Only 5 seconds, it created 50,000 threads. So what do you think? Why is fork taking more time in compared to threads? Why is the fork slower in compared to thread? So fork, we know fork uses copy on write. Copy on write means only modify the pages when there is change between the child and parent process. So even if we are using copy on write, why is the fork very slow? Because when you create a new process, you will have to create a page table. And this creation of this page table and setup cannot be performed by copy on write. So it takes a time to perform page table setup and creation. But when you are creating threads of the same process, this page table is completely split. Hence, fork is a little slower when compared to thread. So there is one more utility known as perf. So perf is also used to measure the time and performance characteristics. So this is out of the scope of this course, but you can install perf, do the performance analysis for language. So it's a perf stat fork. So I run performance statistics on fork. So I need pseudo permissions. So it starts executing the process and then it will calculate all the things and it will display it. So it has displayed performance counter stats for the application. You can see it took this much milliseconds, CPU utilization this much, and this many contexts which happened. And you can see the page faults are on 1 lakh. Now let's run our thread. You can see page faults are very minimal. But this is also okay, very less. The context which is almost the same. So this is the reason threads are very fast. There is very less page faults. Page table creations are not required here. Whereas page table creations are required in case of processes. So let's see one more example we clear like how threads using threads are faster when compared to processes. So before that, if I want to find out how many quotes I have, I can use this command to find out the number of quotes. So get quants, I can even give me all the configuration. Then I say grep for number of processors online. Sorry. It says we have 6 processors in this system. You can also use cat proc CPU info, which will also give me information. So I have like 5, 4, 3, 2, 1, 0. So you can see we have 6 cores here in this processor. So this means I can run 6 threads simultaneously on this processor. So let's see one more example. So in this example, I'm performing matrix multiplication. So I'm performing matrix multiplication. So in this example, I'm using only single process. There's no multiple process here. So this is the code for matrix multiplication. So this is two process, single thread, a process. Whereas in multi-thread, so here what I'm doing is I'm having like files. We have 6 cores, but I'm just keeping it 5, so let's modify to 6. I have 6 cores on the system. So I'm running each and every thread will run this function on a different row of the matrix. So we are passing that as an argument. So I'm passing the row as an argument to the thread, and each and every CPU, each and every thread will perform matrix multiplication on one thread, and then I'm waiting for all the threads to come. So we have a utility known as genome system monitor. So it shows you like how the processes and threads of our application are actually seeing the CPU bandwidth. So you can see that. There's a genome system monitor. You can see it will show you I have 6 CPUs. It is showing the CPU utilization. So each and every CPU, how much is the utilization. I can just say always on a visible workspace. This will be staying here even I show this. Always on top. So always on top, we'll keep it always there. Now if I run the process, you can see one of the CPU is taking 100%. There is a spike for that. So now the CPU is free as a process. So the matrix multiplication using single process is taking one of the CPU. In this case, now it is taking CPU 5. This is scheduled by the decided by the scheduler. You can take any CPU and give it. So it is like 100%. Until the process terminated, it becomes 0%. Now if I do the same thing using thread, you can see almost all the CPUs like 100%, 100%, 100%. It was very fast. You can see the colors are here. All the colors are at 100%. I'll show you. So you can see observe almost 100% used by all the CPUs. And the application time is also very less. You can say time of thread. 3 seconds. As in case of process. Eleven seconds. So you can see how using threads we have quicker output. Efficiently we are using all the hardware which we have here. So each thread which is created using pthread underscore create is assigned a unique ID. So after a pthread is successfully executed, the parent can get the thread ID. But if the thread which is executing wants to know the thread ID, it can call pthread underscore self, which we have already seen in another. So we have this is filled by the pthread library. Suppose this function wants to know the thread ID, it can call pthread underscore self. I'm printing the TID here after pthread underscore create. I'm also printing the TID here. So you can see same thread ID. This is the TID assigned to pthread. This is different than get TID function. That get TID and pthread underscore self or pthread underscore T is different. So there is one more API, pthread underscore equal. This is used to compare two thread values. If two threads are equal, it will give a non-zero value. If they are different, it will give a 0 value. So to compare thread IDs, we have this function pthread underscore equal. So I have created an array of pthread, 2 numbers, and then I'm creating in the main function 2 threads. And here, as this PID is 0, as this PID is global, so I'm comparing this with pthread underscore self. Then I am printing that thread 0 in execution. Else it means thread 1 is in execution. So I'm using pthread underscore equal to compare two thread IDs. You can see thread 0 in execution. Thread IDs. Can anyone, we have seen both pthread underscore exit and pthread underscore join. Can anyone tell us the difference between these both APIs? When should we use pthread underscore exit and when should we use pthread underscore join? And what is the difference which we have observed till now? Okay. So pthread underscore exit will terminate the thread which is called. If you call from your main thread, the main thread is terminated, but your spawned threads continue execution. So anything which you write after pthread exit will not be executed. So this is useful in a scenario where in which your main thread is just needed to spawn threads. You just need to create threads. Whereas pthread underscore join will suspend the execution of currently running thread until a particular thread you want is terminated. After that, it resumes its execution. It is useful where you have to wait until a particular thread completes. If you write return or exit in your main thread, the whole process is terminated. But if you write pthread underscore exit in your main thread, only the particular thread terminates. We have seen this, and remaining threads continue their execution. So can you pass pointers to stack variables from one thread to another? So let's see the code. Is this a valid code? So I'm creating a thread. In this thread, I have this thread function. It has an integer 20 in the stack of the thread. Then I create a thread, and inside this thread function, I'm creating one more thread. The function for this thread is this, and I'm passing the address of the stack variable to this, and I'm then typecasting it to integer. So will it print 20 there?
No.
Here I'm just exiting the thread. So when I exit the thread, it means stack may be removed. And this particular address which we are passing, it may be pointing to some other variable. So let's try this. What we want to do here. So this is not a correct answer. You may get some other answer also. So it depends on like what is present in the stack. So you can see there are some other value. Sometimes I'm getting 20, sometimes I'm getting. So this is not the expected behavior. What about now? I'm calling pthread join, so I'm waiting for this particular thread to terminate. Will I get 20 each time I call this function, this process?
Yes.
Yes,
Hmm.
because the stack will not be deleted for this particular. So each time I call, I'm getting. So you have to be careful about the lifetime of the variables which you are passing. So with every thread, there are some resources are associated like stack, program counter, thread ID, stack pointer, etc. So whenever a thread exits, these resources should be reclaimed by the process automatically. But it will not happen always. It depends on the mode in which thread is running. So a thread can run in two modes, joinable mode, detached mode. By default, a thread is running in joinable mode. Joinable thread will not release any resources even after the end of the thread function. So this is like a wait. Until you call wait, the process is like in zombie state. So similar case is in joinable mode. So by default, your thread is in joinable mode. Joinable thread will not release any resources even after the end of the thread function until some other thread calls pthread join. Whereas in case of detachable thread, resources are released automatically on exit. So there is no need for any other thread to join it. So by default, all threads are joinable. If you want to make a thread detached, you need to call pthread underscore detached with thread ID. So we have seen there are two modes in which thread can run: joinable mode, detached mode. If you want, in case of joinable mode, you have to call pthread underscore join to reclaim the resources. Whereas in case of detached mode, once the function of the thread exits, the resources are reclaimed. So as we said, by default, the threads are created in joinable mode. This means if I need to call pthread join to reclaim the resources, otherwise there will be leaks. If I say this is so let's use Valgrind to find out whether there are any leaks. So Valgrind, leak check, yes, thoughtful. You can see it shows like there are 272 bytes lost. So in our main code, we call pthread underscore create and it call allocate stack. This particular allocate stack is lost. As we have not called pthread underscore join, pthread underscore join was needed to reclaim the resources. Let's modify the code back and call pthread underscore join and see whether Valgrind will report any leaks. Now you can see there is no leaks. The pthread underscore join is needed to reclaim the resources used by the particular thread. Any queries here? So the other mode was pthread underscore detached. So to make a thread detachable, I need to call pthread underscore detached. I need to pass the thread ID. So I pass thread ID here. So I created the thread. So by default, the thread will be in a joinable mode, and the thread function I'm setting it to a detached. So let's see if I don't call pthread underscore join here, will there be any resources lost? Valgrind, leak check, full. So there were no leaks. What happens if I remove this? Will there be any leak? No. There are leaks because we are not changing the default thread mode. The default thread mode is joinable. So, and we are not calling pthread underscore join. Hence, it's showing the leaks. So the other way to set the thread as detached is using attributes. You have to first create an attribute structure. You have to initialize it by using the pthread attribute init, and you have to set the detached state to detached. Now again, there is no need of calling specially pthread detached. Let's see validate again. No resources. So what we have seen is we have two modes, pthread underscore detached mode and joinable mode. By default, it is in joinable mode. We have to call pthread underscore join to reclaim the resources. Whereas in case of pthread detached mode, when the function exits, the thread resources are automatically reclaimed by the process. So we'll see this tomorrow. Let's do a small quiz.
B.
Option A.
B. False.
They are also useful in any processor because the scheduler will continuously switch between threads.
MP3.
LP3.
Option D.
Data.
Data.
FP.
P3 underscore P.
Yes.
Join.
P3 underscore
Option D.
A.
Option A. It's option
B.
company.
A. Option B. The answer is when you have null as an attributes, it calls the hello world function with default attributes. Instead of putting attributes, whatever default attributes, like we have default red mode as joinable. So if you have null here, this means this. Any queries?